Okay, subject of this video is going to be something that probably you could use on any type of a boiler. I blew a tube in this thing. Well, while I was testing the last batch of safety valves, I heard this hissing sound, trying to figure it out, hoping for the best, expecting the worst. And it got progressively worse as I went along the day, and later on, it wasn't even making steam. And I looked in the firebox, and only 2 or 3 of the burners were lit. So it was actually blowing steam out, and I couldn't see any water dripping. No water at all, because it was like here, right here is the flue sheet right there, and the hole is about there. So I'd have to have almost full water in the glass. I usually don't come up more than right about in here somewhere. So that means that the part that was pinhole in the tube was above the steam line, above the water line, and the steam was just coming out in very small amount there. So put it on the side. Happened to have the K4 here. I rigged up, took the T-rig that I usually use on here for doing 2 safety valves at the same time. I took that thing and put it on the K4 and tested the safety valves on the K4, which is, I went through 6 bags of coal to do 14 valves. So think about that. I made a mess and everything. It's much easier with this. I can control it almost. I could set the gas over there and just have it hover right at a certain amount, or I can just have it pop and then pop, pop, pop. I can do a lot of different things with that. And this was rigged up for my injector episode, which I'm still going to get back on, but this back on, over here is the tank. Of course, this is a Mercer valve, and don't ask me why, but that's got the same O-rings, the same everything in that valve as all the other valves. I guess that one batch I screwed up, but all the hundreds that I've made so far, really haven't had a problem with them. Some of these here cheaper valves, they're made in China probably somewhere, they always leak, and then I had visions of having all these different manifold things in here. This comes out and it goes around, and there's a collection tube inside, around the outside top edge of the boiler, right around in here. You can see it through this hole, and it's got holes in it, and that collects. It's like a dry pipe, and it collects that. This is my main safety for 150 pounds. It blows off. The other, I'm taking it off of here because this thing. I don't know why I did. Oh, it made a differential in it. I used this instead. So I take it right off the top of the boiler here. It's like right in this section. Here's where the steam comes out. Now this boiler here, I didn't make it. I bought it from a guy, Steve Dispenza, and it's served me pretty well so far. It needs another paint job, and I'll get around to reconditioning it one day when I get time and change some things about it that I want to do. Because I originally was going to work on this side on this little table. I made a piece of Formica I had left over. There's a polypropylene tank in here that I use for water, and I have a toilet floating there, Fluid Master, and I hook up the hose to that, and it just automatically fills it back up again. It works really great. I have no problems with it. So anyway, the tube. Well, talked to a bunch of guys, Ken Riddle and Don Croce, another guy who's a certified Boilermaker, and he did a lot of, Don did a lot of condenser work, and he said, well, they make the plugs, and I looked at some videos, they get the plugs and they bang them in like a bong, and that seals it up. But I thought I'd go one step further and put a rod with tighten it, I don't want to use a threaded rod. I have it threaded on one end. It's going to be solid here, and I'll thread this end, put a nut on there to pull the 2 bongs, so to speak, in tight, because I'm just thinking that it's going to build up pressure in that tube and eventually to pop them out. So I do it one more step closer, and I wound up making a drawing. Now, I'll tell you a real quick story about drawing while I show you this drawing. I don't know if you can see it. It might be a little light. I think you can see it. One end is threaded and it's blank, this end here. That end there is threaded and blank, and this end is through hole, 64th over 3/8. And I made up here, a packing nut, because one time we did this before on another engine, another boiler, and what happened was the threads leaked. So I made a packing nut to go around it. Just a little packing nut out of steel, and I'm going to put packing around there and pull tight on it. But right now I'm to the point where I'm going to need to get the length of the rod. Here's the tapered plug. I made it out of aluminum. Figure it's soft, and 1 degree taper on this. And I designed it so I measured the inside of the tube as best I can. It's not round, and it's going to tighten up about there, so I'll drive it probably another 3/16 of an inch. And there's my packing side. Put the packing around there and pull it tight. And on the other end, like I said, it's just see if I can get it out. Nothing ever comes out when you want it to. There it goes. And let's see if I can get it out. Get it up here. I gotta put my hand in here and unscrew it. No, watch, excuse my butt, okay? Yeah, it's got the same taper, a blind tapped hole, 3/8/16 coarse thread. What I plan on doing is screwing that in there and put a nut in there, lock it, put it up in there. Now the biggest problem I'm going to have today is getting this boiler up in the air, and I'm going to look at possibly taking it off, I don't know, and picking it up and banging the hell out of this plug, bang it in tight, then put the rod in, put the piece on the top. But I have to determine what the length is going to be. So worst comes to worst, I can put some pack up some washers in there to tighten it down. Because you got a cap that goes on this. In the boat world, it's a funnel, right? Upside down funnel. That goes on top. I had to cut this here because it was just a hole that this pipe passed through, so I couldn't get it off. So I cut it, adjusted it up a little bit, and I had to go back on top with the stack. When I got it, it didn't have a stack. I made this stack. I rolled this up out of a piece of steel and welded it here. And then this piece was the top of a fence post cap that I cut the dome part off, and that worked. But this boiler is a really great boiler, and I'll get a picture of the inside here. And I'm going to put the air in it so you can hear it. So you can hear it pissing or hissing, whatever you want to call it, pissing, hissing, whatever. That one tube right there. I would say about 1.5 inches down from the top, which would make it right about even with this. And I'm sure I'm going to blow this off now. I want to blow it on the locomotive. All right, now here's the end of the thing. I threaded it in a lathe. In the late is John Smith, my dear friend, dear departed friend, John Smith, 46 years old, died of a heart attack. Big shock to me, good friend of mine. Anyway, I'll take some pictures of this thing here, and you can see what the top of this looks. It's got 19 tubes, and I don't really feel like buying the roller. And then don't talk to me about copper tubes. I'm not a guy who likes copper tubes. It is two dissimilar metals, and the copper tubes expand and contract, and I'm a believer in stainless. Now, I might put stainless in this boiler; it'll last me forever. But I don't know how old this boiler is. I've had it for 6-7 years. And I fire it up all the time, and I have fired up for a full day. I put treatment in it, but that don't help too much. It doesn't even have a, I guess I could coal fire. It doesn't even have it's open on the bottom, completely open. But I got a turkey burner in the bottom, natural gas. Man, that works so good, no problem. Easy peasy. So, it served me well. I can't complain. I'll get this the tube blocked up, and I'm sure that another one's going to open up. But if I can get a couple of more years out of it, then I'll figure out a way to get these tubes out. Now, that's an issue in itself, trying to get the tubes out. One person suggested Ed Archer, who had some experience in that, put another hole bigger than the tube that you have, and punch them out, and then bring them through that hole. There's a special cutter that's on an angle. You can go around on the inside there and cut the tubes. There's like a tool that goes in, and you turn it, and when you turn it say clockwise direction, the tool comes out and it scrapes the inside and it cuts through. When you turn it the other way, it retracts and you can pull it out. And that may be a way to get them out of there. You still have to get the tubes out of the boiler. So it's not an easy task, but I would put other steel tubes back in it again. They measure 1 inch and 80 thousandths on the ID. So I don't know what how thick they are or whatever, but I'd have to get the roller, and I don't have the roller, and the rollers are not cheap. I got one over here for 3/4 that a guy gave me for doing. This is for doing 3/4 inch flues for copper, and I have those. I have it just in case I have to do them. And it's a company's called Wilson, and they make all kinds of rollers. I have the roller for that purpose, but like I said, I'm not a big fan of copper. I'd either weld steel in. On this boiler I have stainless, and the boiler I built for Dan Hoarding's K4 identical boiler to mine, stainless, 1/2 inch stainless pipe, which is 109,000 wall, approximately 3/32. And I've used steel on all my other boilers, steel pipe, seamless pipe, Schedule 40. It's just standard steel pipe. I think they corrode, they rust out after a while. And the biggest problem you have with them, if you have an arch, the draft is so great that it actually erodes the top of the flues off by going in. I've seen that issue happen. Eats right through it, like sandblast it. So that's the one thing you got to worry about, stainless or any tube, any metal. But that could happen to copper, even worse. But people insist on using the copper. I'm not a copper guy. I'll never be a copper guy. And if you ask me to build a boiler and it can't be steel, then I'm not building it. End of story. You can go see Marty. Marty's the copper guy. So. And he's built successful boilers. I can't say nothing about it. I just don't like doing it. It's my preference. A Chicago, Chevy, Ford, Lincoln, Cadillac thing. Okay, well, I'll let you know what the progress is going to be. I hope to get this together today, and maybe we'll complete this video by having the thing all completed and not leaking. Hopefully, we'll see what happens. So we'll see you on the next part. Okay, well, I made the plug, put it all together. It's leaking a little bit around it. You know, I put some of this stuff around it. You got little bubbles, but I banged it in tight. I told you it's going to leak. Now, right next door to it, the pipe next door to it wasn't leaking before, and now it's sprung a leak because of pressure. I put my finger on the hole. So it's tiny, tiny little hole. That's how the other ones started out, and they got bigger and bigger and bigger. So rather than make a whole nother thing, I'm going to try the bongo method, the bulb. Just put a aluminum 1 degree taper and bang it in there and see what it does, and see if I can block it off. See, I'm holding it right now. Expansion, everything will heating up. Maybe it'll get tighter. I don't know. We'll see. I'll come back to you. All right, well, I made another plug. This one was just a 1 degree taper, no threaded rod or anything, and I beat the crap out of it, put it in there, and it's still got little bubbles in there. You can still see it. But you know what? I'm going to give it a try and see what happens. And maybe we got enough time today to fire it up. Yeah. Okay. Up to 100 pounds right now, and it's building quickly, so my plugs are working for now. See what happens. Maybe it'll blow, I don't know. But there's a little hissing. Well, it's just that leaking until it gets hot. Woo! Wow, that's way off. Let's see what this one is. These are Bob Chamberlain's. He sent me back. He tried to set them and he couldn't set them. And that one's only set at about 110. Let's see what this one's set at. I can see already I'm going to have to change the screw on that one. See, they're originally designed for 120, and if I want to get more pressure out of it, I got to put washers underneath the screw. Went up 145, 150. Still ain't popped. Let's see if we reset that. Try the injector. $70. Wow. Okay, well, I don't play around with these safety valves right now. I don't feel like doing it. I gotta take them apart, clean them, redo them. Whenever I buy safety valves, you shouldn't really mess with them because it takes me quite a while to set them, to get them perfect. And if you don't know what you're doing, you really start getting it out of adjustment. So right now I got to rework these a little bit, clean them up. They were originally set for 120, 125. Now the customer wants 130, 135. So that means I'm going to have to change the screws, get longer screws, and do some other little fancy things inside. But the main thing is here that my repair of the boiler worked. So we're in good shape until I blow another two. And then when that happens, I'll either plug it or put new tubes in it when I get a chance. I can get another set of safety valves out, another 20, 25, which I have working on, then get through that and then we'll see what happens. But anyway, hope you enjoyed the video. Thanks for watching. We'll see you again on the next video.